the notes for lesson 5.5, completing the square. Before we get into what completing the square is, I want to review factoring. So we have x squared plus 6x plus 9. So if we factor this, we want factors of x squared, so x and x on the left hand side. On the right hand side we want factors of 9, or our last term, and we want them to add up to be 6. So we're going to have to use 3 and 3. So our factors are x plus 3 and x plus 3. And we know that this can be written as x plus 3 quantity squared. Second example, we have x squared minus 8x plus 16. Again, we have a trinomial, so we're just going to set up our t. X and x on the left hand side. On the right hand side, we want factors of positive 16. That will give us a negative 8x. So that's going to be negative 4 and negative 4. If we cross multiply, we get negative 4x and negative 4x, which is negative 8x. So our factors are x minus 4 and x minus 4. So again, we have x minus 4 quantity squared. So again, I told you guys before that I want you to write it as the binomial quantity squared, because that is what we're looking at for completing the square. So what would cause x squared plus 6x plus blank to be a perfect square? So in order to find what this blank is going to be, we're going to take the coefficient of our second term, or 6. We're going to divide it by 2, and that gives us 3. If we square 3, we get 9. And so that's what we need to write to complete, or to have a perfect square. And we're going to use that same process when we complete the square. So the formula for completing the square is right here. So x squared plus or minus bx plus b over 2 quantity squared, which is what we did right here. And that is equal to x plus or minus b over 2 quantity squared. So we're trying to get some quantity squared so that we can then solve for x, or for our variable. So you might ask why we would want to complete the square. This method allows us to use the square root method to solve quadratics that cannot be written as ax squared equals c. So as we talked about before, in order to use the square root method, it has to be in the form ax squared equals c, so it can't have that x term. We also know that there are trinomials that cannot be factored, so in those cases where the trinomial cannot be factored, we can complete the square. That way we can solve using the square root, because we don't really have any other method that we can use yet if it can't be factored. So to complete this square, we first have to rearrange the equation so that it looks like this. So we have x squared plus bx plus blank, or our square, equals c plus that same blank. And we're going to figure out what that blank is in just a second. So for part 2, if x does not equal 1, divide every term by a. So if the coefficient in front of our x does not equal 1, then you have to divide that out. So we have to have a 1 in front of our x squared term in order to complete this square. So for part 3 in the squares, we're going to write b over 2 quantity squared. And we looked at that in the previous example. So you're going to take your b value, which is the coefficient for your x term. You're going to divide that by 2 and then square it. And again, those are going in the squares, or the blanks. Step 4, you can then rewrite the left-hand side as x plus or minus b over 2 quantity squared. Now the plus or minus will determine what will be determined by the sign in front of your bx term. So if it's positive, it'll be positive. If it's negative, it'll be negative. So you're only going to pick one sign. Then once we have rewritten the left side as x plus or minus b over 2 quantity squared, then we can take the square root of both sides to get rid of the square, and we can solve using square roots. We just have to make sure that we don't forget our plus and minus for our answer. Whenever we take the square root, we know that we have 2 solutions. So again, completing the square will always work. It's especially helpful when trinomials can't be factored, and when it's not in ax squared equals c format. So again, if it can't be factored, if we can't use the square root, completing the square will work. for our examples, we are solving by completing this square. So again, if we review the first step, we need to change our equation so that it looks like ax squared plus bx plus our blank, or our square, equals our c value plus our square, or our box. So essentially what we are doing is moving our c term over to the right hand side of our equation. So for this one, we're going to add 3 to both sides. So we get x squared plus 10x plus our blank equals 0 plus 3 is 3 plus our blank. So whatever we add to one side of the equation, we also have to add to the other. So that's why you'll see a box on both sides of the equation. So then from here, we need to find out what needs to go in our box. Remember, we take our b term, so that's what's in front of our x, so that's 10. We divide that by 2, which we know is 5, and then we square that, which is 25. So 25 is going to go in both of our boxes. So then from here, we can write it as a binomial squared. So we have our x. It's going to be positive because our middle term is positive, and the square root of 25 is 5, or our b over 2, so 10 over 2 is 5, and that equals 3 plus 25, which is 28. So now notice we have a quantity squared. To get rid of our square, we can just take the square root. Remember, we take the square root of both sides. So we get x plus 5 equals, if we take the square root, we know it's plus or minus the square root of 28. Now if you remember from 5.4, we can simplify this radical. So we're going to do our birthday cake method. So 28, I'm going to divide by 2, and that will give me 14. 14 divided by 2 is 7. 7 divided by 7 is 1. So notice we have a group of 2's. So we still have x plus 5. And that equals plus or minus, so 2 on the outside of our radical, and the square root of 7 on the inside of the radical. And again, we want just x, so the last thing I need to do is subtract 5 from both sides. So x equals negative 5 plus or minus 2 square roots of 7. Now remember, our real part comes first, so that's why I wrote the negative 5 first, and then your radical comes second. So my final answer is x is equal to negative 5 plus or minus 2 square roots of 7. For part B, again, we want to move our c term, so we're going to subtract 5 from both sides. So we get x squared minus 12x plus our box equals 0 minus 5 is negative 5 plus our box. Now to find out what's inside our box, again, we're going to take b over 2 quantity squared. So our b value in this case is negative 12. We divide that by 2. We get negative 6. Negative 6 squared is 36. So in our boxes, we put 36. So then from here, we can write this as a binomial squared. So we have x minus 6 quantity squared equals negative 5 plus 36 is 31. Now to get rid of our square, we can take the square root of both sides. So that gives us x minus 6 equals plus or minus the square root of 31. 31 is prime, so if we set up our birthday cake, we wouldn't get any pairs. So we can leave that as is. So lastly, we're going to add 6 to both sides. So x equals 6 plus or minus the square root of 31. And that is our final answer. Our last example, part C, we have 2x squared plus 12x plus 9 equals 0. Now, before we can do anything, again, we want the coefficient in front of our x squared to be 1. Notice in parts A and B, our coefficient in front of our x squared is 1. We don't have a coefficient, so it's just 1. So before we can do anything, we have to divide everything by 2 in order to get our coefficient as 1. So if we divide by 2, 2x squared divided by 2 is just x squared. 12x divided by 2 is 6x. 9 divided by 2 is 9/2. And 0 divided by 2 is 0. Now from here, again, we want to move our c terms, so we're going to subtract 9/2 from both sides. And that gets us x squared plus 6x plus our box equals negative 9/2 plus your box. So from here we need b over 2 quantity squared. So our b value is 6. 6 divided by 2 is 3. 3 squared is 9. So we have a 9 that goes in our box. So we can write this as x plus, again, our b term, our middle term is positive, so that makes our sign positive. And then this is x plus 3. And this equals negative 9/2 plus 9 is positive 9/2. Because 9 is the same as 18 over 2, and 18 over 2 are 18/2 minus 9/2 gives us a positive 9/2. So then from here, we're going to take the square root of both sides. So we have x plus 3 equals plus or minus the square root of 9/2. Now before we do anything else, we need to simplify the square root of 9/2. We know that we cannot have a radical in the denominator, and this can be written as the square root of 9 over the square root of 2. So we have to multiply by the square root of 2 over the square root of 2, so we can get rid of that radical. So in our denominator we have the square root of 2 times the square root of 2, which is the square root of 4, which we know is 2. In our numerator we have the square root of 9 times the square root of 2, which is the square root of 18. Now we need to do our birthday cake to simplify 18. I know that it's divisible by 2, and that gives me 9. 9 is divisible by 3, and I get a 3. 3 is divisible by 3, and that gives me my 1. So I have a group of 3's and a 2. So this is 3 square roots of 2 over 2. So I have x plus 3 is equal to plus or minus 3 square roots of 2 over 2. And then lastly, I need to subtract 3 from both sides. So x equals negative 3 plus or minus 3 square roots of 2 over 2. And again, that is my final answer. So again, completing the square will always work, even if we cannot factor a trinomial or if it's not in the form to use square roots. So completing the square will always work to solve. So I just want to review our 3 methods for solving quadratic functions. The first one we talked about is factoring. Remember that factoring sometimes works. It has to be in the form ax squared plus bx plus c equals 0. And again, we have to be able to come up with those factors, which won't always work. So sometimes we will have trinomials that are prime and we cannot factor them. The second method that we talked about is square roots. And again, solving with square roots sometimes works. In order to use the square roots, it has to be in the form ax squared equals c. Again, if we have that middle x term, we cannot use the square roots. And lastly, we just talked about completing the square. And completing the square always works. Now, it always works depending on what numbers you are working with, as far as if there are coefficients in front of your x squared term, if we're dealing with fractions. Completing the square is not always pretty, but again, it will always work. So again, the 3 forms of solving quadratic functions are factoring, square roots, and completing the square. And in the next section, we're going to talk about our last method for solving quadratic functions.